Hi, Math 2 students. Today we're going to be covering piecewise functions. So a piecewise defined function is one which is defined not by a single equation but by two or more. Each equation is valid for some interval. So basically what this means is that certain pieces of the function are defined differently depending on what your input is, okay? So this is what the like if you were to write out the function, this is what it might look like. This is an example of one, and I actually plotted this here, and this would be an example of you graphing it, just so you kind of have an idea of what these things look like. All right, so let's go ahead and get started here. So for this first one, this is a piecewise function, and we know it's a piecewise function because it's two different definitions based on the interval you're on, okay? So in this case, they want us to find f of -5. So if we look, that means that our x value is -5. And we know that for x values that are less than or equal to -5, we have to use this function here, okay? Putting in a -5 here works, right? You could always just like plug it in, make sure it works. -5 equals -5. So we just go ahead and plug a -5 in here. So we're going to do -5 plus 8 squared plus 4. So we end up with 3 squared plus 4. We get -9 plus 4, which is going to be -5. All right. So that is how that works. All right. Again, you have to use the definitions over here on the right to kind of, or I should say the intervals here on the right to figure out which function you're going to use. All right. So here it says find f of 5. So we're going to be using this function. And the reason we're going to be using this function is because it fits the constraint here. 5 is greater than or equal to 4. And in this case, our output is literally just 1. You can't plug anything in there. All right. So your output is 1. All right. So for this one, it says that when x is not equal to -1, so that's literally any other input than -1, we would use the first function. For the second one, it says x is equal to -1. Well, our x is -1, so we're going to be using this second function here. Our output is -1. Try the next one. All right, and we have an input of 2. All right. First function we use when the x value is not equal to 1. Well, 2 is not equal to 1, so we're going to be plugging into that first function there. So we're going to plug in a 2, and we get 0. All right. Okay, and we're actually going to go ahead and skip page 4, go on to page 5 here, and we're going to evaluate it graphically, okay? And basically the thing you need to take away here is that this thing right here is called a hole, okay? Or a jump discontinuity. And basically, what happens here is this guy, this filled in hole, trumps the open hole, okay? And you'll kind of see what that means. So here it says find f of 1. So basically they're saying, okay, our x value is 1, find our y value, okay? Well, when we look at an x value of 1, that's right here. And right, if we look up here, we've got a hole. That's no good. We have to go where it's filled in. So our output here would be -1. That would be our answer, okay? Here, they want us to find f of 7. So we've got our input as 7. And if we look here, there's no hole or anything there. Our output is just 1. All right, so 1 would, what the heck? 1 would be our answer here. All right, next one, they want us to find f of 6. Well, if we look at an x value of 6, we appear to have two outputs, but remember, we don't use the guy that is open, so we're going to use our closed hole here of -2. And then we got f of -4. We've got our input of -4. What's our output here? And that is going to be -5. So our answer would be -5.